on this concept VAB. He had given RA and RB. The question was, given electric field E bar is equal to x ux plus y uy plus z uz volt per meter, find the potential difference between 2 points x2, 0, 0 and y1, 2, 3. So you have to use this equation to solve the problem. Okay. Now let's take this equation VAB, the potential difference between 2 points, VAB as minus integral RB to RA E dot dl. What will be the work done in moving a charge Q1 from B to A? We know potential difference between these 2 points is nothing but the amount of work done in moving a unit positive charge from B to A. Instead of unit positive charge, if I have a small charge Q1, then what is the work done in moving the charge Q1 from B to A? How will you find out? If you know the potential difference, then the work done from B to A can be found out as the charge multiplied by the potential difference between these 2 points. Important 1 mark question, right? So, and you know VAB, mathematical representation of VAB, that is integral RB to RA E dot dl. So the work done in moving a charge Q1 from B to A is W is equal to minus Q1 integral RB to RA E dot dl. So this is how you calculate the work done in moving a charge Q1 from B to A. And if the question is asked from what is the work done in moving a charge Q1 from A to B, then this will be work done W is equal to Q1 into VBA, that is minus Q1 integral RA to RB E dot dl. Now, what happens if RB is equal to RA mathematically? If RB is equal to RA, then if I just use this equation, VAB is equal to minus integral RB to RA E dot dl, since the upper and lower limits are the same, we know this VAB will be equal to 0. The integral will be equal to 0. Right? So, what do you mean by integral becoming equal to 0? What is the physical significance? Because we know if you integrate from RB to RA, this will result in VAB, and finally that will result in the work done. Right? And if I say this is equal to 0, that means the work done in this case is equal to 0. Right? Let's take this example. From B to A there is some amount of work done, and then RB equal to RA means again you move from A towards B. Then the position vector will be the same. Right? So the final position vector is same as the initial position vector. So RB is equal to RA. That means you form a closed loop in the vicinity of this charge Q. So there is a field in the vicinity of this charge Q. If there is a closed loop that is formed and the charge moves in a closed loop in the vicinity of the field produced by electric charge Q, what is the work done now? What is the work done? So the amount of work done in moving a charge, a unit of positive charge or some other charge in a closed loop in this field is equal to how much is the work done? Either you take the example of you take the case of the mathematical model or the one that we have seen just now. So total work done in moving a charge Q1 in a closed loop is equal to how much? This is equal to 0 for this case. Right? Is equal to 0. You start from B, go to A and then come back to A. That means you form a closed loop here. So if the work done in moving a charge in this closed loop is equal to 0, that means there is no energy dissipation due to the movement of the charges in this closed loop. We know that when the charge moves from one point to another point, there should be some energy dissipation, right? So, but in this, the field that we have considered, so if the charge moves from one point to another point in the closed loop, then there is no energy dissipation associated with this field. So, the amount of the total work done will be equal to 0, or the energy dissipation is equal to 0. This is, in fact, exactly same as what we discussed few minutes back, that is about a conservative field. This is a conservative field, and electrostatic field is an example of conservative field, right? So there is no mechanism by which the energy represented by the work done is is dissipated. That is a conservative field. Now, if you map this concept to your circuit theory course, where you have several, you would have discussed several complex circuits, right? Like a series RLC circuit or parallel RLC circuit, whatever be the case. Closely observe that whatever circuits you considered, they were all closed circuits, right? So something like this: R, L, and C. They're all closed circuits. And also recollect the fact that every circuit has a source that is attached to it, right? Source is the one which is going to generate the energy, and this is always a closed loop, right? So always you consider closed loops, and energy propagation or that may lead to energy dissipation, okay, is due to the source that is connected to the circuit. If there is no source, then there is no concept of energy propagation or energy dissipation in the circuit, right? So, like when I said there is no energy dissipation, okay, why is there no energy dissipation in this field? Okay, strictly speaking, there should be energy dissipation because there is a movement of the charge from one point to another point. Even if the charge moves from one point to another point in this closed loop, this should lead in some energy dissipation, but that doesn't happen. We are saying that energy dissipation is zero. That's because the energy that is supposed to be dissipated by this field is compensated by the source which is connected to this circuit, or the source which is generating the field. So the energy, whatever is the amount of energy that is dissipated due to the movement of the charges in the field, is compensated by the source that is producing the field. Right? So here, if charges move, if you talk about current I flowing through the circuit, that means there are some charges flowing through the circuit, right? So when the charges flow through the circuit, that should lead in energy dissipation. Some amount of energy will be dissipated, but that energy would be compensated by the source that is connected to it. The source, the example of a source would be like, a battery, a photovoltaic cell, right, or a generator. So these are all source of energies, and then you need to always recharge the batteries, or recharge the generators, so that they constantly they keep producing the energy. So that's what typically happens in the usage of electricity, right, or any circuit which has some source connected to it. So